Let's apply what we learned about parametric functions and their derivatives using this formula, dy dx equals dy dt divided by dx dt. And let's apply them to some explicit functions here. So I have x equals t squared, y equals 7 minus 8t. So what we want to do with these particular things is let's just go ahead and compute dy dt and dx dt, and then we'll plug them in the function or in the formula. So the time derivative here, the derivative of t squared is just 2t, and then dy dt is negative 8. Since that derives to 0 and negative 8t derives to negative 8. So then we plug this in, we say dy dx is dy dt divided by dx dt. So that gets me negative 8 over 2t, or negative 4 over t. And so that's really all you need to do here. For our next problem, it's going to be a little trickier, but the principle is the same. So what we do is we go ahead and get dx dt, and we get dy dt. So dx dt. So another thing to think about is writing things in terms of the root is kind of not fun. So let's write it as a fractional power. So instead write it as xt to the 1/7. This allows us to use the power rule. We can say that's 1/7 t to the negative 6/7. That's one way to write that. And this will actually be easier to leave it this way for now. So then for y, we'll do dy dt is negative 1. So then when we plug this into the formula, we're going to get dy dx is dy dt, or dx dt, which is negative 1 over 1/7 t to the negative 6/7. Now, there's a couple things we can do here. Is if we multiply both top and bottom by 7, we get negative 7. So the 7 on top is here, and the 7 times the 1/7 makes this sort of vanish. So we get t to the negative 6/7. And now if we remember that when a power is negative, you can swap it. If it's in the numerator, you can swap it to the denominator. If it's in the denominator, you can swap it to the numerator, and it just flips the sign there. So we end up with negative 7 t to the 6/7. And that's how you do it. I mean, it's really just following a process. As we get to like the second derivative, we're going to have to be a little more in depth, but this is the basic process.